1600. Welcome back to the channel. Recently I tried to build a tachometer or a Rev Counter by using Arduino Pro Mini and IR sensor, and I tried to get a code from the other YouTubers, and I noticed the code doesn't work, and I also searched for different type of codes from the other YouTubers, and I noticed most of the codes either doesn't work, or if it works is not accurate. The code I came up with is basically a push button counter, and is literally it counts the pulse. The pulse can be from a bottom, or it can come from the IR sensor. So this is the wiring diagram that I used for my wiring up my Arduino Pro Mini. So as you can see, the code is very basic. I used some libraries to run the OLED display, and for the code for counting the pulses I just used the for statement with some condition. And after doing that, I just wanted to make sure I'm running the code for exactly 1 second. And the way I did it, I connect my oscilloscope to the Arduino, and I measured the loop, so how long it takes to repeat. And it was very easy. If you're wondering how I did it, I just simply turn on an LED after my loop, and at the beginning of my loop I turned off that LED, so the duration between the state is changed from off to on. It should take about 1 second, and by adjusting the value in the for statement, and I managed to get the duration of the for statement, the code that it runs, for exactly 1 second. So within the 1 second it counts the pulses, and after that it prints. After 1 second it prints the result to the OLED display. After finish the code, I built a enclosure for the tachometer. Also, I made a switch that a rocker switch that used magnet for breaking and for connecting the circuit on and off, and also the magnet works as a spring to rock the switch from on to off state. Now if you're wondering how accurate this device is, here is my impact driver, and it operates at a different speeds. So we got 3 different modes: slow, which is about 1600 rpm, medium 2100 rpm, and at the highest mode is it operates at 2800 revolution per minute. And let's put it on slow. $1,600. At the medium, so it was 201,000 rpm, and at the highest mode, I mean, we get 2880. Like, the wave you see on the screen is because of the camera, and when you look at the OLED display, it's very stable. I don't know why on the camera it's just showing the wave. Thanks for watching. I leave the link below for downloading the parts and the codes. See you next time.